right, so in the previous videos, we looked at moving functions in one way at a time. And in this video, I wanted to talk about moving them in multiple ways and what happens when you put multiple movements together in one function. So just like in the other videos, I'm going to start by making up a parent function. So maybe I like absolute value of x plus sine of x. That looks pretty cool. And then I'll define a new function, g of x, and I'm going to do two things to it. I'm going to go f of x minus 2. Notice that moved it to the right by 2 steps. And then minus 3 moved it down by 3 steps. So if there's a particular point that is on the red graph, for example, the point 0, comma 0 is a nice one to look at, then I know that there's going to be a point that's 2 steps to the right and 3 steps down from there. So I know that there's going to be the point where x is equal to positive 2 and y is equal to negative 3. And I can see that right here. You can also see that any of these points is directly related to points from the other function. Every x value from the red graph gets shifted right by 2 steps, and then the y value gets shifted down by 3 steps. It's easy to see with 0, 0, because 0 plus 2 is 2. 0 minus 3 is negative 3. But the same thing is true with, for example, this point right here. If I shift from negative 2 and I go 2 steps to the right, I'm going to be at 0. If I look at the y value of 1.09, blah, 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 and subtract 3, I'm going to be at negative 1.909. So every point on the red graph moves 2 steps right and 3 steps down. But we can do even more things than that. We can also take this graph and we could reflect it. And what I want you to notice, and this is a little bit interesting, is that the order of the operations matters here. I taught you in the reflecting video that putting a negative in front of the function reflects it over the x-axis. Now watch what happens here. Does the function actually reflect over the x-axis? No. What you can see here is that the function reflects over this point right here, the line that goes to that point, which I could type in as y equals negative 3. If I pop a negative in front of f, it flips it over that function, y equals negative 3. So why is it flipping over y equals negative 3? The reason is the order of operations. When you put a negative here, you're multiplying your function by a number, by negative 1. And then after you multiply, you're subtracting 3 from the function. That's the order of operations. You multiply first, and then you add or subtract afterward. So the same thing is true if I make this, for example, a 5, and I get a much taller function. It's 5 times farther away from y equals negative 3 because I stretched it by 5 before I shifted it down by 3. Okay? So the order of operations is the same thing as the order of our transformations. What that means is that your multiplying and dividing happens before you're adding and subtracting. And it also means that your parentheses happen first of all. So within the parentheses, we do the minus 2 first, moving it to the right. Then we do the reflecting or the dilating, depending on what kind of number I have in there. You can do both a reflection and a dilation. And then you do the adding or subtracting at the end. So let's see, for example. Okay. Now, there is a little bit of a complicated nuance here, which is, what if I want to reflect it or dilate it horizontally? So for example, keep your eye on this point right here of 2 comma negative 3. I'm going to make my function twice as narrow. Now what I want you to notice is that point went to 1 comma negative 3, but the 1 doesn't show up in my equation anymore. When I had nothing multiplying the x value, you could see the 2 very clearly showing up as that point where the origin point had moved down there. But when you put a dilation in there, you lose track of the 1. It gets even a little weirder if you put a negative in front of it, or -2. So the thing that you can do that makes it easier is you can factor it. So if I write 2x minus 2, that's going to be the same as if I wrote, let me define a different letter, h of x. If I write it like this, f of 2, and then I go parentheses x minus 1. You might wonder, where did I get the 1 from? I got the 1 from thinking about distributing. If you look at 2 times x and 2 times -1, you should see how it's the same as the inside of f of x. And when I factor it, then you can see the order of operations a little bit more clearly. So the order of operations says that you're going to do parentheses first. And so what that means is, first, I'm going to shift right by 1. And then here it is the horizontal dilation. And then you have here your shift down by 3. So I just wanted to mention that in general, when you have more than one function transformation, you follow your PEMDAS order of operations. And if you have a hard time seeing the order of the operations, you can factor out your horizontal dilation. So please let me know if something was confusing. Happy to help out. Thank you.